Welcome to the Crazy Hat Chemist. So here's another video in bonding. Bam! So we're going to determine the hybridization and bond angles for number 8. What is number 8? Number 8 is sulfur tetrafluoride. That's SF4. So you're going to review 2 videos before you continue on with this one. One of those videos is drawing the Lewis dot structures for number 8. That's sulfur tetrafluoride, and determining the molecular geometry of number 8. That's also sulfur tetrafluoride. From those 2 videos, you're going to get the information that you see on this slide currently. That is the Lewis structure in black and white there. That is a central sulfur atom with 4 sets of single bonds attached to fluorines, and then a single lone pair of electrons on the central element of the sulfur. From that Lewis dot structure, you should be able to get the AX4E for the axe-like structure. There's 4 bonding domains and 1 non-bonding domain on the central element. The name of the shape, geometric shape, is disphonoidal or seesaw. So I'm going to show that to you once again here. Here is the disphonoidal seesaw shape. This is what this looks like. Hopefully you can see that. This is really where the seesaw comes from, just like that. You should see that. Okay, so disphonoidal or seesaw. It has a lone pair of electrons on the central element here. And just like I had mentioned in the previous video, that is determining hybridization and bond angles number 7, it was a trigonal bipyramidal structure. And I mentioned that lone pairs of electrons, of which this is that I'm holding on to right now, lone pairs of electrons must go in the trigonal planar structure of a 5-domain trigonal bipyramidal electron domain structure. And that is because the trigonal planar structure has bond angles of 120 as opposed to the poles at 90. Lone pairs, of which I'm holding on to again, need more space. That's why they're in the plane. So this is disphonoidal or seesaw. Disphonoidal or seesaw. Hopefully you can see that. Okay, now what we're going to do is we're going to get the hybridization of this. We're going to count the electron domains around the central element here. Okay, and that is 1, 2, 3, 4, 5. So hopefully you got that. So that's going to be S, P1, P2, P3, D. So that's sp3d hybridized. Now, if we look at the trigonal bipyramidal structure of electron domains, then the central region here, the trigonal planar structure, is 120 bond angle. And then we have 90. Now this lone pair of electrons is going to compress all those bond angles. So that means instead of 120 right here within the plane, I'm going to have less than 120. Instead of at the poles of 90, I'm going to have less than 90. So I'm going to have less than 90, less than 120 for my bond angles. Okay, so let's get that written down here. So I've got my hybridization, that is sp3d hybridized, and my bond angles are less than 90 and less than 120. You could have placed the less than 120 first and then the less than 90. It doesn't matter in terms of the order. They're both perfectly fine. Okay, I got another crazy hat for you today, and this is my cork hat. This is from Australia, and this is to generally, as you just move your head just slightly, you keep the bugs away. Okay, I always figured, you know, you keep big, gigantic bugs away. This hat can be very annoying unless you look far away from the pieces of wood or corks that are hanging from this hat. Every now and then, I wear this hat when I have pesky students. How about that? Anyways, just kidding on that one. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I will see you next time for more cool chemistry videos. Lots of learning going on. All right, talk to you later. Bye now.